In this video, we're going to identify the key features of a parabola from its graph. The parabola we'll look at involves an application. We're given that a toy rocket is shot into the air at a speed of 48 feet per second. Its height after x seconds is given by the equation y equals negative 16x squared plus 48x for 0 less than or equal to x less than or equal to 3. Looking at its graph, we can see that the x-axis is labeled with time in seconds, with x, which is time in seconds, and then the y-axis is labeled with y, which is the height measured in feet. Looking at the points on that graph, we can see that it goes through 0, 0, and then comes up to the point 132, hits a maximum of 1.5, 36, and then comes back down to the point 232, and then lastly hits the point 30. So let's get started. Looking at these key features, we're going to look at whether the parabola opens upward or downward. We'll look at the vertex, the axis of symmetry, both the horizontal and vertical intercepts, and then we'll state the domain and range. The last thing we'll do is to label some things, each of these things, on the graph itself. So, with regard to whether the parabola opens upward or downward, we're looking at the direction basically that it curves. And so we see this point 1.536 as the maximum point, and from there, all of the points are below it. So this parabola is opening downward. And just for a quick visual, I'll draw a couple things above. So for upward, we'd see a parabola that curves upward, and for downward, we'd see something opening downward. The vertex is either the highest or lowest point on a parabola, and in this case we see that the highest point on that parabola is 1.5, 36. So that is our vertex. And if we wanted to interpret that, that means that the maximum height is 36 feet, and I'll write that real quick. The max height is 36 feet. And if we want to say when it occurs, so I put a semicolon there to finish, it occurs after 1.5 seconds. Okay, looking at the axis of symmetry, the axis of symmetry is the vertical line that passes through that vertex. So I'll draw one real quick. And I'm going to draw a dashed line through that vertex. And I can see then that all of the points around here, it goes through the point 1.536, there's symmetry with respect to the points, the rest of the points on this graph, and they're symmetric about that line, which is x equals 1.5. So again, that's a vertical line, and it's the axis of symmetry, and it's defined by x equals 1.5. That's our vertical line that we see, and all the points are symmetric about that line. The horizontal intercepts is a general term for intercepts, for that horizontal axis. Here, these are x-intercepts, so I'll note that. And that's coming from that our variable on the horizontal axis is x. So the x-intercepts, or the horizontal intercepts here, are the points 0, 0, and 3, 0. And again, those are the points where the graph hits that horizontal axis, or in this case, the x-axis. The vertical intercept actually overlaps here with one of the horizontal intercepts because this graph happens to pass through the origin. So our vertical intercept here, which for this particular variable is the y-intercept, is going to be the point 0, 0. And that occurs wherever we hit that y-axis. And so here we have the point 0, 0. Lastly, let's label the key features on this actual graph. So the vertex was the point 1.536. So I'm going to draw an arrow to that and denote that that's the vertex. The axis of symmetry, that was this line, x equals 1.5, and I can denote that that's the axis of symmetry. The horizontal intercepts, which in this case were the x-intercepts, were the points 0, 0, and 3, 0. So I'll draw some arrows to those. Those are my x-intercepts. And then lastly, this point 0, 0 was also a y-intercept here, or a vertical intercept. So I'll label that. And those are the key features of this graph that we have drawn.